Consider this peak rectifier circuit. If you switch the diode with the capacitor like this, we observe an interesting phenomenon. If you feed this circuit with a square wave, such as this one, we see that the capacitor will charge to 6 volts with the polarity as shown. This polarity reflects the direction of current which depends on the diode connections. Remember that the diode allows current to be conducted in one direction. The capacitor voltage magnitude is equal to the most negative peak in the input signal. We can see it is 6 volts here. After this value is attained, the diode turns off and the capacitor retains its charge indefinitely for a theoretical circuit. Notice that the output voltage is this, V0 equals Vi plus Vc. So the output waveform will be identical to the input. However, it would be shifted upwards by the voltage across the capacitor. Our output will therefore be like this. The voltage levels are now 0 volts and 10 volts, shifted upwards from the input by 6 volts. The diode never lets the output voltage go below 0. Whenever that is happening, it conducts and charges the capacitor through the source and causes the output to rise above 0. However, because the cathode is upwards here, the diode won't constrain the positive voltage level of 4 volts. As a result, as you can see from this figure, the lowest peak of the output will be clamped to 0 volts. This is why this circuit is called a clamped capacitor. However, if we reverse the diode polarity, you will see that the highest peak of the output waveform will be clamped to 0 volts, something like this. In both cases, the output waveform will have a finite average value or DC component unrelated to the average value of the input signal. If a signal is passed through a capacitively coupled system, it is going to lose its DC component. Passing it through a clamping circuit is going to give it a definite DC component. This is why this circuit is also called a DC restorer. It is particularly useful when calculations involving duty cycle require the average value of the signal to be known. Duty cycle calculations are utilized in pulse width modulation for carrying information. However, we will not be covering that in this course.